Lang stands for language models. Chain stands for what? Isn't it beautiful? Custom functions used as runnables are called RunnableLambdas. There are three types of chaining. That variable I'm passing to the prompt, that I'm passing to the LLM, and then I'm going to parse. Now we are ready to create our parallel runnables. This is actually deprecated. Smart software engineers are learning to build apps based on LLMs. And congratulations if you are trying to do the same, because you are in the right place. Now imagine that you have already built your app using OpenAI API. Now let's think of some problems that you can run into. Suppose with time what happened was that OpenAI's API became very costly. And there are other LLMs out there which actually started offering better solutions at cheaper price. So now you want to switch from GPT to say Llama or Gemini. But now you will have to switch all your code. You will have to make the calls again and again. And it is going to be such a complex process. Another problem that can happen is that you have your own startup. Now you have some data that belongs to you, right? Now if you're just making call to GPT has no idea about your data, right? So how do you make sure that that data can also be read? So you need some tool so that your app can also understand your data and also learn from GPT, and based on this give you combined really good responses. Now another problem that you can run into is that GPT does not have latest information. So you also want to be able to read latest information from the net. So how are you going to do all of this? Exactly. This is why we need a common framework where switching LLMs should be very easy. Today you are using GPT. Tomorrow if you want to use Llama or you want to use Gemini, it should be very easy. Such complex processes should become very easy. Having external tools, integrations should be very, very easy. And this is exactly what LangChain does for us. So LangChain is the framework that is going to help you build apps using LLMs. So I hope you have understood why is LangChain very, very important for you to understand. It is going to be extremely famous and you really need to understand this. It is going to help you save so much of your time and it is very easy to understand. And we have so much to cover in this video. So let's get started. This is the official documentation of LangChain and this is what we'll be referring to. This is about building a simple LLM application with chat models and prompt templates. So as you can understand, chat models and prompt templates are very, very important topics and we'll be focusing on them. The documentation over here is just amazing. But let's get started with simple setup for now. See, the focus is going to be on building the app in this video. So the setup that we are going to use is going to be very simple. Just run Jupyter Notebook, and the Pandas tutorial was also on Jupyter Notebooks. But for absolute beginners, what you have to do is just go over here, go to install the notebook, and all you have to do is pip install notebook and Jupyter Notebook, and that's it. Focus on building the app for now, okay? Now, moving on to the documentation. See, the awesome part about this documentation is that it is not just focused on OpenAI. Although in this video, we'll be using OpenAI API to build our application. The awesome thing is that after this video, you'll be able to use any LLM and still be able to build the app. That is the whole point of using LangChain, right? So here, if I select like Google, so you can just use Gemini model. Similarly, if I just say NVIDIA, you can use the Meta Llama 3 model. So like this, all you have to do is just say, "Ki, I want to use so-and-so API," and you'll be able to go ahead with this. So to be able to use the OpenAI, we have to set up an OpenAI API key. So this is the very first step in order to get started. We have to set up the OpenAI API key, and then we'll move ahead and understand it. How can we get started? So let's do this first. Before we move ahead, I would just like to take a moment over here to share something with you. Over the last few months, I think all of us have realized that ML/AI is the future. And that is why you're watching the video. It makes sense to read about it, to study it, and be future ready. And I've been doing the same. Over the last few months, I've spent so much time on ML/AI. In fact, we have a product called Taxstop, which is currently live only for the Educosys students. But we are integrating a lot of AI stuff into it, and I'm learning so much over there. Also, we have been designing a live hands-on generative AI course. We have finally launched it. It's a 7 weeks course. You can check out the curriculum over here. It has 10 projects, some small, some quite big projects, but it is going to be completely live and I'm just so much excited for it because here you will not only be learning about generative AI, you'll be building, deploying and applying generative AI. The last hands-on course that we did was hands-on high-level system design course, which we call HHLD. That was MERN plus DevOps plus HLD. That is still one of the most enrolled courses on Educosys. I have seen so many students not only develop up end-to-end projects, scalable projects, but deploy them and add them to their resume. It was one of the most satisfying things that I have done as part of Educosys, as a software engineer, as a teacher. That's when I decided that I want to do more hands-on courses, and I'm really excited for this, and it's going to be live, so I hope to see you there. Like all the other courses, you will get access to the recordings, to all the future live batches, and you will get the access to code, notes, everything. You can check out the details, you can check out the testimonials of all the other courses, and I'm really excited for this. But for now, let's continue. I hope to see you there. For now, let's continue. In order to set up OpenAI API Key, just go to platform.openai.com. You will be able to see all the documentation over here. A lot of details is there. But just go to dashboard, go to API keys. See, right now I have 2 secret keys. These are for my projects. What you can do is create a new secret key over here. Just give some name, like for example, text project, and create the secret key and copy it and keep it somewhere. Make sure you save it because you will not be able to access it later and we'll be needing it. So I'll be using this one and I'm deleting the one that I just created. This is how you can also delete it. So what you have to do now is the copied secret key. Just go to the same folder where you'll be creating your notebook file. Create a .env file over here and just write OpenAI API Key. And whatever key that you had saved, it will be something like SK something, right? So just paste it over here. I will do the same right now. And after this, we are ready to get started with writing our code. I have pasted the secret key in our .env file, and let's finally get started with writing the code in our notebook. I'm going to be doing pip install python.env. So that's fine. And now what I'm going to do is I'm going to be importing OS. So anything whenever you are dealing with operating system right now, we need to load the environment variables. So this is just to load that OpenAI API key, okay? So just some boilerplate code right now. I'm going to be importing OS, and then from .env, we are going to be importing load.env so that we can load our environment variables. So I've loaded the environment variables now, and now I can get our OpenAI API key and I can read it like this. So os.getEnv, and over here we had used the variable OpenAI API key. So now that we have loaded our OpenAI API key, we can finally get started with writing our code, and let's go back to the LangChain documentation. We are going to start interacting with our LLM. In our case, it is going to be GPT, and you're going to be amazed by how simple LangChain makes it for us. Just check it out. So here it is given that from LangChain OpenAI, we have to import chat OpenAI. What is chat OpenAI? It is a chat model. What is a chat model? Let's finally understand it. Let's go back to the top. Here it was mentioned that we are going to build the application with chat models and prompt templates. What are chat models? Let's check out this documentation using language models. I'm just going to go over here. Here it is mentioned, LLMs are typically accessed through a chat model interface. Let me make it very simple to you. Basically, whenever you want to interact with any model, with any LLM, okay, you're going to be accessing it, you're going to be interacting with it via chat model interface. So in LangChain, what they have done is they have created separate packages for each provider. Like for example, if we are using the OpenAI provider, the package is going to be LangChain-provider. So let me show it to you over here also. So because we have selected OpenAI, we are going to be using which package? LangChain OpenAI. Suppose it was Google, then the chat model name is Chat Vertex AI, and we are importing from where? From LangChain Google Vertex AI. Similarly, if it was NVIDIA, then the chat model name would have been Chat NVIDIA, importing from where? From LangChain NVIDIA AI points, right? So it makes it so simple for us. We are going to be using OpenAI, the chat model that we are using. So basically, this is just a way of interacting with the LLM, with the GPT. So we are going to be creating a chat model, which is chat OpenAI. Okay, so that is what we are going to be importing. Let me actually just copy paste this. Also, to be able to get this chat model, we have to use any of these packages. Okay, one is LangChain OpenAI, or we can use the community also, LangChain community. It is given that the models are mostly contributed and supported by the community, so we can use this as well. And see, the models are named with the convention that starts with chat. So the names are like Chat Olama, Chat Anthropic, Chat OpenAI. The documentation is just beautiful. So if I show you this documentation also, here they have mentioned all of this, right? So we have already done the API key part. We just need to create our model and start invoking some messages, right? Basically, we are going to send some instructions to our LLM. So what do we need to do? Firstly, I need to import this chat OpenAI. First, let's install the packages. So I can install either LangChain OpenAI. I could also do LangChain community. Let me actually show both. So LangChain community, and I'm going to just run this. And now I'm going to be just pasting this. So I'm importing chat OpenAI. Okay. And we are done with this. We can finally get started with calling our LLM. So I'm calling it LLM. You can call it anything. Most people call it LLM. You can call it OpenAI LLM model. You can call it anything. Okay. So I'm calling this method chat OpenAI to create our LLM. So OpenAI, we can mention the model over here just like it is mentioned in the documentation. We can mention the model. I am leaving it as it is for now just to get started. And now I can invoke the method invoke. And what I'm going to do is I'm just going to give an instruction, like how to ChatGPT we give instructions, right? Tell me this, tell me that. Just like that, I'm going to give an instruction. Suggest me a title of movie to watch. Okay, so any movie to watch, so suggest me some title, and we are going to save the response over here, and let's check out what response we are going to get. And I'm going to just run this, and here we have gotten a good response. Here in the content we can see there is a name that is present over here, right? So let me actually also just print response ka content. So if I do that, I can see the midnight sky. If I run it again, then it is Midnight Serenade. Okay, suppose movie in Hindi to watch. Okay, and let me run this. So it is saying Adbhut Yatra. Okay, so we can watch Adbhut Yatra. So congratulations, we just interacted with GPT. Actually, we gave an instruction to GPT and it responded us with some content. Also, for those of you who are interested, just wanted to show you something cool. See, LangChain has amazing documentation. Okay, so here you can check out all the providers that they support and the package names and the additional functionalities that they have. So over here, if you go back to the documentation, you can see these chat models usually offer these additional capabilities. So suppose tool calling. We'll be discussing and seeing these in a lot of detail in the coming videos also, but this is like a higher level idea. We will check out other providers as well, right? So right now in this video, we are using OpenAI. But these are the usual capabilities, right? So tool calling meaning, do they support external tools? Structured output meaning, can they respond in a structured format? Like for example, JSON. Multimodality meaning, do they support only text or do they also support images, audio, video? So that is multimodality. So like this, they have mentioned that these are the providers. These are the functionalities that they support. So if suppose you want to explore, for example, Vertex AI. So you can see, okay, these are the functionalities. This is the package name. So you can see the documentation and you can actually check it out, right? One more thing that I wanted to show you was that when you're creating the model, like Chat OpenAI, right? You can obviously give a lot of configurations. We had seen in the documentation, we can mention the model, right? We can see over here the default model that we are using is GPT 3.5 Turbo, but you can use 4.0, 4.0 Mini, like this. You can mention which model you want to use. Another very common thing that usually people mention is temperature. Okay, so let me actually show it to you. So you could actually give it like this, temperature. The value is between 0 and 1. So 0 means that you want your model to be very, very precise. Okay, basically you do not want any randomness, you do not want any creativity. So suppose you're doing any summarizations or any calculations, when you want a lot of precision, that is when you give temperature equal to 0. When you're creating the model itself, you are saying that this is how I want my model to behave. Suppose you want your model to be very, very creative. Suppose your tasks are poetry, storytelling, or any creative task. So you can give a higher temperature. So suppose 1 is the highest temperature. So your model is going to be very, very creative. So the usual temperature that people give are like 0.6, 0.7. 0.7 is a good enough temperature, right? So that is like a medium level, not like extremely random, not very, very precise. So it basically plays around and gives you good responses. Coming back to the code that we have written, every time I'm running this, you can see I'm getting a new movie. I'm just deleting this chat OpenAI new model. Now here what we had done was LLM.invoke. We had called the method invoke. If we look at the documentation over here, we had called the invoke like this. We had just passed the instruction. But if you see over here we are passing something called messages and they have formed some message. Here also there is something happening, role, content. So what is exactly happening over here? If we go back to the definition of chat models, here it was written that LLMs are typically accessed through a chat model interface that takes a list of messages as input and returns a message as output. So message seems something very important, right? Let's check out the documentation of messages. So if we go over here, it is mentioned messages are the unit of communication in chat models. They represent the input and output of chat model as well as any additional context or metadata that may be associated with a conversation. And two very important things that you need to understand in a message are that every message is going to have a role and some content. Okay, and they have given a very good table showing that. See, the possible roles are system, user, assistant, and so on. System role meaning that you are telling a chat model that you have to behave like this. Like, for example, you have to behave like a teacher or a software engineer or an expert in something, a marketing specialist. What role do you have to take? That is the role that you're assigning. Okay. User meaning you're giving the input. Okay. Assistant, the output that you're getting, the response. So here you can see messages can be of the type system message for the content which should be passed to direct the conversation that you have to behave like this. Human message for the content in the input, AI message, the response, and then multimodality for the information on multimodal content. So this is how we can give the invoke also. So here if we see, let me actually just copy paste this entire thing and whatever was given, okay, so the whatever is given in the documentation, I'm just copy pasting that and I'm invoking our LLM. Okay, so invoke and I'm going to pass this messages. And if I run this, so it said ki translate the following from English to Italian. Okay, we have not imported it, so we have to import also LangChain.core messages. And let me just, okay, and let me run this again. And here we can see the content is ciao, okay, ciao. And if I run this again, here we can see, okay, I have not put it in the response. So let me put this in the response. And once I run this, now it is there in the response. And if I run this, you can see ciao, right? So this means that now the response is ciao. So if I actually run it like this, okay. This is how you can pass messages, system message, human message, AI message. So this is what you should understand. Over here also, instead of messages, what they have given is, they have actually given the message. See, this is one message, role, user, content, this, hello. So this is one message, right? So like this, you can give a list of messages also. So here by default, when we did this, it was by default a human message saying hello. So that is what it is taking as the input. In this code that we had written, we had passed this instruction, suggest me a title of movie in Hindi to watch. Now suppose I want to do this. I want my user to be able to select in which language they want to watch the movie. Here I have hard-coded Hindi, right? Now I want my user to be able to select ki I want to watch suppose in English, Hindi, Malayalam, Tamil, Telugu, French, Spanish, anything, right? So I want to take an input from the user, then transform the string and then send to our LLM. So then I will suggest me a title of a movie in this particular language to watch. Now, not just language, I can also take more inputs from the user. Like for example, genre. I can take that my user wants to watch in this particular genre. It can be comedy, sci-fi, horror, anything, right? So I want to be able to take inputs from the user, transform it and then send to LLM. Similarly, in this example, I want to be able to take the input from the user and tell ki translate the following from English into some other language, or from some language into another language. It can be from Hindi to Malayalam, it can be Telugu to Tamil, it can be anything, right? So I want to be able to take from the user, transform it, send to the LLM. Now let's go back to the documentation and see how it can be done. So there is one more concept that we saw, which is very important other than chat models, and that is prompt templates. And it is very simple to understand. Okay, just look over here. It is constructed from the combination of user input and application logic, just what I told you, right? So application logic usually takes the raw user input and transforms it into a list of messages ready to be passed to the language model. Prompt templates are a concept in LangChain designed to assist with this transformation. They take in the raw user input, return the data, a prompt that is ready to be passed to language model. So what is going to be passed to the language model? The prompt is going to be passed. So for now, let's just copy paste the example that is given to us, and then we will do the same thing for our movie example also. So I'm just going to copy paste this and try it out. Okay, and let's copy this part also. This is where we are forming the prompt. Okay, okay, first let's run this. Okay, so here what did we do? We imported chat prompt template from LangChain core.prompts. Then we gave a template, and let me actually run this. So here we can see that we actually created one prompt. Okay, what was there? In system messages, the system message was translate the following from English to Italian. See here we had given translate the following from English into some language. Now where did we take the input? The input was given over here. See, this is a dictionary where it is given that in place of language, pass Italian. Okay, in place of the text, pass hi. That is why we got the output as chow, right? We can pass anything. Suppose we want to pass it in Hindi, and instead of hi, we want to say, suppose, how are you? Okay, and let's try running this. And now when I run this, translate the following from English to Hindi. And what is the text? How are you? So this is just the prompt. Now we can invoke the LLM by passing this prompt. So now when I pass the prompt, let's run it. Okay, I have to aap kaise ho. Okay, and I can also save it in response, and I can just print the content also. So I have transformed it to aap kaise ho. Now similarly, suppose we want to do in Spanish. That is again, how are you, right? So Spanish, how are you? Let's try running it. So this is the Spanish of how are you. Okay, similarly, suppose if we want to say in English and Hindi only, in Hindi, suppose what is your age? Simple. Okay, and let's run this, and we should be able to see तुम्हारी उम्र क्या है. Correct? So if we go and look at the documentation, what did we do so far? We created prompt from the prompt template, and then we passed it to the model.invoke, and then we were able to get the response, right? So we have followed this. But see, now there are many ways of creating the prompt template. So if we actually go to the documentation of prompt template, let me do that. Okay, let's go to the prompt templates, and here you can see we can also create prompt templates from template itself. So what we had done so far is we had created the prompt template from messages. So we had obviously passed messages over here, system message, user message, and so on, right? We can also create it from template itself. So if I actually go over here, chat prompt template, and I do dot, so you will be able to see from messages, from roles, strings, from template. So similarly, let's try this example also, and then we will try writing the code for the movie example that we took, right? So let me just copy paste this. Here, when we do prompt template.invoke, what are we going to get in return? So let me actually run this. We got a string prompt value. Tell me a joke about cats. How did it get cats? It got it from this topic. We had passed it in the dictionary, right? So this is essentially a prompt. So I'm going to assign it to the prompt. And then when we do LLM.invoke, I can pass this prompt value. Okay, and now let me run this. And you can see the output, right? Why did the cat sit on the computer? So this is a joke, okay, to keep an eye on the mouse. Okay, so this is supposedly a joke. If you want to see just the content, you can also do this response equal to LLM.invoke, and then you can just do response.content. Okay, and why was the cat sitting on the computer? Because it wanted to keep an eye on the mouse. So you can see just the content. So what did we do? We created prompt template from template, then we got the prompt, and then we passed it to the LLM. So this is one way of writing code. Now let's try for the movie example that we had taken. Let's get started with creating a template first. So I'm going to call it movie title template, and I'm going to be creating from prompt template. So from template, and I'm going to say suggest me a movie to watch in language and of genre And to be clear, let's suggest me a title of a movie to watch. Okay, in this language and in this genre. So this is the template. Now we are going to create the prompt. So movie title prompt. And we are going to get it from template, right? So movie title template, and we are going to invoke it. And now we have to pass the inputs that we want to give, right? So we have to pass it as a dictionary. So I am going to pass language as, for example, English, and genre, suppose horror. And then we are going to get response LLM.invoke. And let's see the response for our movie title prompt. Let's run this. And let's print the response.content. And here we can see title of a movie. If I run again, we'll be able to see different. And if I suppose change the genre to, say, for example, comedy, you can see. And if I suppose change it to Hindi, you will be able to see Golmaal. Now we are going to discuss the core concept of LangChain, probably the most important concept of LangChain, so listen carefully. See, from the name itself, Lang stands for language models. Chain stands for what? So in LangChain, we can create chains of a lot of things. Now, chain of what? What is each component, or what is each step in this chain? So think of any function, any process, any action, any task that you can perform, you can create a chain of that. So in this chain, each task or each step or each component or this function or task or action or anything that you're performing, that action is called a runnable. Now let me explain it to you in very simple terms. What did we do so far in order to create our application? We created a prompt. That is one task. We did something, right? We created a prompt. Then we passed it to the LLM. That is one task that we performed. Then we got a response from the LLM. Now the response had a lot of things. Content was one of the things that we wanted to parse and get out, right? So that parsing is also one task, one function that we are doing, right? So any task that you can run, any function that you can call, any action that you can perform can be a runnable. And you can chain these runnables. So you can chain these steps or tasks or actions, okay? And you will be amazed to see how beautiful and simple LangChain makes it. So right now, all the code that we have written, it is very simple to just write it in form of a chain. And let me show it to you. We are back to the LangChain documentation, and I am at docs concepts runnables, and the documentation is just awesome. Let's read about Runnables. Runnable interface is the foundation for working with LangChain components. And if we go down, they have given the different components that can be runnables. Every runnable is characterized by an input and output type. So each of these components are different runnables. For these components, these are the inputs and these are the outputs. Let's check them out. So the prompt that we had created, what did we give? A dictionary. That for this language, like put this value in the dictionary, right? So like fill the variable with this value. Like for example, we had given Hindi or English. Genre we had given, right? Comedy or horror. So we gave in a dictionary, and what did we get as the output? Prompt value. Similarly, in ChatModel and in LLM, like to talk to the LLM, we use ChatModels, right? So what can we give as the input? A string, a list of chat messages, or a prompt value. So when you are using ChatModel, what are you going to get as the output? Chat message. LLM, we are going to get a string. Then we can have output parsers. So the output that we got from the LLM, we were parsing what? We were parsing out content. So there are different parsers that we can use, and we can get the output accordingly. Then there are retrievers, there are different tools, right? So these are all components. So you can have chains of these components. These will be each task or action or process or function that you are performing, right? And if you go down and look at the examples, this is one of the examples that they have given us, okay? You can create a chain of prompt, then pass it to your model, and then you can pass it to your output parser. So each step is divided by this pipe operator, okay? It is very easy to understand. Whatever will be the output from this prompt, that will be passed to the chat model. Whatever will be the output from this chat model, that will be passed to this output parser. I think we are ready to convert our code into this format and see if this works or not. Let's do this. So what I'm going to do is I'm going to create a chain now, and I'm going to call it movie title chain. So we already have a prompt, right? And I just need to pass the template actually. I don't even need to invoke it. So I'm just going to take this and I'm going to pass it to the LLM. Now I can also parse it, but for now let's just have two things in the chain and let's run it, and then we will also parse the output. Okay. Now you can see that I have created the chain. Chain is there. I can invoke this chain now. Now you will think, where will I give this input, right? At language and genre is this. That is when you invoke the chain, you will give that this is the input that I want to give to this particular template, right? So what I'm going to do is I'm going to invoke the chain, and in this I am going to pass our dictionary. So this is the input that I want to be passed to my first component for now. Okay. So let's run this and let's see the output. See, we got the output and we got this, right? Now in this only I want to add another component in the chain and I want to parse this output. So I'm going to add yet another component, and what I can do is from LangChain core, I am going to dot parsers. I'm going to import str output parser, and I am going to add another component str output parser, and I'm going to call this. And now if I run it again, see, pagal banti. And if I run it again, isn't it beautiful, right? So now if I pass English, if I pass suppose horror, I don't know why, but okay, Haunting of Hill House. So this is so beautiful, right? So simple way of writing the code. Here we had to do so much. We had to create the template, we had to invoke, then we had to do invoke. This is a very simple way of writing code. Okay, and one more thing, in most of the tutorials that you will see on YouTube, you will see that they are creating the LLM chain using this. Okay, and you will see that they are importing. So you will see most of those videos are like 1 year ago and all of that. This is actually deprecated, and I'll show it to you in the documentation also. So just see as of today, like you can think of early February 2025. This is the documentation, and I think they plan to keep this because this is part of LCEL. So I think this will be continued, this way of writing the code. So I think this you can use, but in case if there is any update, I will be updating in the comments. But I think this is what they are planning to keep in the future also, because this is very easy to understand, right? You just have to add the pipe operators. Just showing you in the documentation also, see over here they have mentioned that this class, the LLM chain class, is deprecated, and they're telling to use the pipe operator instead. And if you go down also, I think here it is mentioned that call is now deprecated, use invoke instead, right? So just refer to the code that I have written. By the way, the link is in the description, so you'll be able to refer to all of this code. Basically use the pipe operator, save your time, don't go behind LLM chain class. Let's come back to the code that we had written. And now what we are going to do is we are going to add one more step over here. And till now, what is the output that we got? We got the title of a movie. We are going to make another call to the LLM, and we are going to say, give me summary of this particular movie. Now, you might be thinking that, Keerti, that is not required in whatever template that we had given, whatever instruction we had given. Over here itself, we can just say, give me the title and then give me summary also over here. And you're right. While it is true that I am giving you a simplified example right now, let me also make you think that why would we want to add more and more steps? See, sometimes it might happen that for one particular task, like for example, for getting the title of a movie, I want to use a particular LLM. Suppose I myself have some database, and from there itself I want to get a title. But to generate the summary, maybe I want to use another LLM. Maybe in order to save some cost, or maybe I want to use my own LLM. Right? So there can be multiple reasons why I want to make different calls to different LLMs. Also, having different steps in the chain makes it easier to debug, makes it easier to log, makes it more flexible. You can understand, right? Yes, our basic software engineering principles also come into picture over here. We want to keep our chain as flexible as possible. So actually, let's get back to writing the code. What I'm going to do now is create another prompt, and I'm going to call it movie summary prompt. Okay, and this is going to be similar to the movie title prompt. And what I'm going to do is just like how we did prompt template, right? So prompt template, and from template we are going to do, and we are going to give me, suppose let's make it very specific, 2-3 line summary of the movie, and let's give the variable movie title. So we have this prompt now. Now I want to create another chain with this new step, right? So I'm going to create a composed chain. And what I need to do is, first I need to call the movie title only, right? The movie title chain. So I need to invoke the movie title chain, and then from that I'm going to get the output that I'm going to pass to the movie summary prompt, right? So I'm going to call movie title chain. I'm going to pass it whatever is the output to the movie summary prompt. Whatever is the output, I am going to pass to the LLM. Whatever is the output, I am going to pass to the output parser. Correct? Now this movie title chain, okay, whatever is the output, I need to save it in this particular variable, right? Movie title. So what I am going to do over here is, I am going to put it in a dictionary that for this movie title, you will get the output from this chain. And this chain internally is doing what? It is seeing, okay, this is the template. I'm going to call the LLM and I'm going to parse it. It is going to parse and get me out the movie title. I'm going to save it in this particular variable, and that variable I'm passing to the prompt, the summary prompt, that I'm passing to the LLM, and then I'm going to parse it. So let's run it and see. Okay, I have created the chain. Now I need to call it, right? Obviously. So invoke, and now when I invoke this is where I am going to give the language and the genre. So this is the input that I am giving to the first component of this chain, which is the movie title chain, right? So let me actually pass it and let's run it. Okay, I added one extra braces and let me run it now. So after inheriting an old mansion, a young something something, right? So we did not get the movie title over here. Why not? Because I'm not printing the title. What I did was I just got the summary. In order to print the title also, there are obviously many ways, but I want to introduce one more concept and let me actually show it to you. So if we see how to run custom functions. So right now what we are doing is we are just creating the prompt and then passing it to LLM, parser and all of that. What if I want to write my own custom function in between as a step? Like in our example, what we are going to do is write a function to print the title. So I just want to introduce how to do that, right? So here you can see, so you can use arbitrary functions as runnables. This is useful for formatting when you need functionality not provided by other LangChain components, and custom functions used as runnables are called RunnableLambdas. So for custom functions, we are going to use something called RunnableLambda. Okay. Now, before going through the documentation, let me actually make it very simple to you and write it myself. So what we are going to do is, first we need to obviously import RunnableLambda. So I'm going to just copy paste this from the documentation. And let's go back and over here. So in this chain only, first I am going to import it. And here, before like sending to the prompt for the movie summary prompt, I'm going to add another step. Okay. And I'm going to call it as print title step. Okay. Print title step. And we are going to write our own custom RunnableLambda over here. And for this, I'm just going to do RunnableLambda. And what I'm going to pass over here is, so I'm going to write a lambda function, and whatever x is the input, right now I'm just going to print the x as it is. Okay. If you notice over here, the input that I am giving is this dictionary. Okay. Why I had created this dictionary? Because prompt expects a dictionary. That is why I had created the dictionary. So if I actually run this now, let's do that. And if I do this, you can see that I got this as the output, movie title, haunting of something, and then the summary of it, right? So instead of getting the dictionary, if I want to print just the movie title, I can do this. Okay, right now I created the dictionary because I wanted to pass to the prompt, but okay, I'm just simplifying it for you for now. And if I run this, here you can see the title, A Nightmare in the Woods, and then the description, the summary of it, right? Now, it is not necessary that I have to write it separately. By the way, if I just comment this out and I copy paste the step over here, this will also work. But this is obviously not a very nice way of writing code, right? So you can create a separate function altogether. Okay, so you can see again the title and then this. So there are many ways of writing this code. Let me actually undo and so that it will be there in the code. Let's look at one more example that's given in the documentation to be absolutely sure that you are understanding what's happening over here. So here they have created a prompt, and the input that they're giving to the prompt is that the topic is bears. Okay, so this is the dictionary input that they're giving. Tell me a story about, so the topic is bears right now. They created the model, and in this, so they created the prompt, passed it to the model, and then whatever was the output, they got the content. So the content would be just the joke, and then tell me the story, right? So it would be the story, and then you're slicing the first 5 letters out of it, right? So the story must be starting something from once upon a time or something like that. So when you slice it down, you get only once as the output, right? So this is how you can actually play around with it. You can write your own custom lambdas. Here they have actually mentioned that when writing your custom functions in chains with the pipe operator, you can omit the RunnableLambda or chain constructor and rely on coercion, right? So you can actually check out the examples over here, and you can try writing different examples. You can play around with it, write your own custom functions. It will be a lot of fun. Let's talk about chaining a bit more. See, there are 3 types of chaining. Let's talk about the kind of chaining that we already saw. So what did we see? One task happened, and after that task finished, another task happened. After that task finished, another task happened. So these tasks happened in sequence. So that is why this type of chaining is called sequential chaining or extended chaining. Now you can imagine that if I am talking about sequential chaining, what would be the other type of chaining? That I can perform the task in parallel at the same time. I can perform the task concurrently. So this type of chaining is called parallel chaining. I am sure you can think of so many examples. Let's consider the example that we are only seeing, and we will write the code for this also. Suppose I have the movie summary now. Now I want to translate and see this movie summary in other languages. So suppose I have it in English, I want to translate it to Malayalam, Hindi, Telugu, Tamil, Spanish, French, whatever, right? So these translations can happen at the same time. They can happen parallelly. I don't need to wait, okay, you will translate first to Hindi and then to Spanish or then to French. No, right? I can do these parallelly. So the second type of chaining is called parallel chaining. The third type of chaining is called conditional chaining, and from the name itself you can understand that based on some condition, some tasks will happen and some tasks will not happen. So that conditions will decide which task to do and which task to not to do. So in short, there are 3 types of chaining: sequential or extended chaining, parallel chaining, and conditional chaining. So the code that we had written was using the pipe operator, but we can also use something called RunnableSequence. So if we go to the documentation, you can see that all we have to do is write RunnableSequence and then just give what all tasks we have to perform. So over here in this code only, let's try writing the same thing using RunnableSequence. So what I'm going to do here, just how we imported RunnableLambda, we are going to be importing RunnableSequence, and then we are going to create the compose chain using the RunnableSequence. Okay, and here we just have to pass all the tasks that we have to perform, and instead of the pipe operator, all you have to do is pass commas. That's it. So instead of the pipe operators, I am going to pass commas. So just different ways of writing code. I'm just showing you because the other 2 ways are very similar to RunnableSequence, so you should know these types, right? So I'm just going to run this and I'm going to call it again. And let's see, the haunting shadows and the summary is also set. So this is how you can actually write this. Coming to invoking runnables in parallel, we can use something called RunnableParallel. And here in the diagram also they have shown that the same input is given to multiple branches and then they combine later. Okay, and if you want to see the code example, you can just click on this and we can see the examples over here. So we can just call RunnableParallel. Let's see this example. This is very nice. So here they have created 2 chains, joke chain and poem chain. So this is just going to tell a joke about topic and this is going to write a poem about topic. You can see that the input is same in both topic, right? So here they are doing, I think, .stream, Runnable.stream. You can do Runnable.invoke and you can give the common topic. So the topic over here is bear. And these 2 chains you are going to pass in the RunnableParallel and you will be able to run them. So here also, let's come back to the example and I am going to be importing just how we had imported sequence and lambda. So I am importing RunnableParallel and now I need to create 2 chains that I am going to be running in parallel. For example, let's do translate to Hindi and translate to Spanish. So let me just create the 2 chains. Translate to Hindi chain. And I'm first going to create the prompt. So actually, let's create the prompt first. And I'm going to do chat prompt template. And from template, and I'm just going to write translate the summary to Hindi. Similarly, translate Spanish. Okay. Now we have both the prompts, and now we are going to chain these, right? So if I actually just call this as chain itself, and I'm going to chain it over here. So this is the prompt, and I'm going to pass it to the LLM, and I am going to also parse it, right? So I'll have the output. Similarly, I'm going to pass this to the LLM and pass this to the output parser. Now we are ready to create our parallel runnable. So I'm going to call it parallel runnable, or let's call it translate runnable, so that it is clear that what we are trying to do. And here I am going to do runnable parallel, and I'm going to pass these two. Okay, so suppose I am saying Hindi translate, and I'm going to put translate Hindi chain over here. And similarly, I'm going to say Spanish translate, and I'm going to put translate Spanish over here. So I've created the parallel, and now we just need to invoke it. This should be called translate, missed the S over here. So translate runnable dot invoke. And what do I need to pass? I need to pass the output from this as summary. Okay, so it is expecting summary as the input. So I am going to pass it in the dictionary. So I'm going to do summary. And from where will I get it? Whatever output I got from over here, right? So I am going to call this as summary, and I'm going to put it over here. And now we can run this and see. We will have to run this again to get the summary. And we have it. And now let's run this. By the way, if you're wondering why I did not print the summary, because I am not printing, I'm just assigning the value. So if I write here print summary, it is going to print it. So let me just run it so that it is completely clear. Because I assigned it, it is not printing, right? And now here you can see I have the Hindi translate and the Spanish translate. And if you want me to print just that, we can also do that as well. So here in this, suppose let's do translated summary. And over here, I am going to print translated summary ka Hindi translate and the Spanish translate. And let me also write that what we are printing so that it is clear. So Hindi summary and Spanish summary. And let me run this. And now you can see this is the Hindi summary and this is the Spanish summary. Awesome. Coming to the third type of chaining, which is called conditional chaining. Now imagine if I tell you that based on whatever we have learned so far, you can actually achieve conditional chaining. Think of it. We learned something called RunnableLambda. Let me know in the comments how many of you could actually think about RunnableLambdas over here. If not, all the timestamps are there. Okay, so the video is divided properly. Just revise and practice all of this. Try writing the code yourself and you will understand these things. Okay. The basic concept is that we can write our own function, our own logic in RunnableLambda, right? So what we can do is pass in some variable, some input to the RunnableLambda and have logic that if this is the variable or based on some logic, I want to call this branch or I want to call this branch, invoke this or do this, right? And coming to the documentation, that is what they have also mentioned. Firstly, what is routing? Routing allows you to create non-deterministic chains where the output of a previous steps defines the next step. And there are two ways to perform routing. The first is conditionally return runnables from RunnableLambda. And this is what they're actually recommending. There's one more way using RunnableBranch, but this is legacy. So what they have also given the example that just write your own RunnableLambda. Suppose here there is some info and you can have something like if else. If this is the info, just convert it to lower and then use this chain, otherwise use this chain, right? So they are taking the input and if it is anthropic, they are calling the anthropic chain, otherwise they are calling the LangChain chain, right? So like this, you can have your own functions. And So because we've already done RunnableLambda, I am not going to be writing the code again for this. I hope you have understood. Let me know in the comments if you still have any issue. And they have actually written it in the documentation that this is a special type of Runnable, but it does not offer anything that you cannot achieve from a custom function as described above. So we recommend using a custom function instead. So that is why I also don't recommend, because it is given in the documentation, don't use RunnableBranch, just write your own custom functions. This brings us to the end of the video. I hope you like the content. A lot of effort goes behind every single video. See, now there are two more topics that are remaining in LangChain. One is creating RAGs and the other one is agents. So I want to create dedicated videos on both of them, how to build them, the details about them, what are they for beginners, right? All the videos in the machine learning playlist right now are actually very beginner friendly. I'm literally going through the documentation telling you this is how you can get started. And I'm showing you everything, right? I'm telling you reasoning behind every single thing. And I know that there are still so many software engineers who have not accepted that this is the future. They should be upskilling right now. So you have no idea how much it will mean to me if you can just share it on LinkedIn, comment, share it with one of your friends. It will really help me reach more people, because I genuinely truly believe that these videos deserve to reach more people. And if you also think so, help me reach more people so I'll be motivated more and I will be able to deliver more and more content, right? I want to create a lot of free content, but I really need your support. So please do help me out and see you next time. All the best. Please try out writing the code yourself and let me know if you have any doubts. See you next time. Bye.